Good day, grade 12. So this is a first video for our study and revision. So what I'm gonna do, play video, is to look at a revision term 1. Now remember, term 1 has its topics as the 4. This is the annual teaching plan, term 1 for grade 12. So for term 1, you have its topics as a 3. As you can see, you have momentum and impulse from week 1 to week 3, and then one vertical projectile motion from week 4 to week 5, then organic molecules from week 6 to week 9. There is another topic abangayifakiyo grade 12, which is Newton laws. So zizonke topics ezakho zenzayo ziyi-4. So this is your ATP. I send you ATP yako ku WhatsApp, so I'm not gonna read everything that per topic what you must know. So as you can see, you have all the necessary information per topic. So quest topics before, this is your exam guidelines. There are things that you must know per topic. For example, with Newton laws, you must be able to define normal force, you must be able to define frictional force, static frictional force, kinetic frictional force. You must be able to state Newton's first law, Newton's second law, Newton's third law. You must be able to state Newton's law of universal gravitation, describe weight. So you'll get all of this in your WhatsApp group. I sent you this document, exam guideline yako per topic. And then the second topic, which is momentum, you must be able to define momentum, define linear momentum. You must be able to state Newton's second law of motion in terms of momentum. You must be able to define impulse. You must be able to use the impulse momentum theorem. Also, you must be able to know what is internal and external force. You must be able to state the principle of conservation of linear momentum and distinguish between elastic and inelastic collision. So this is the work that we ask for momentum. And then we go to projectile motions. You must be able to define a projectile, define free fall. So these are the two definitions that are very important in projectile motion, and then be able to use your equations of motions to calculate velocity, acceleration, displacement, etc. And then be able to do graphs, velocity versus time graph, position versus time graph. So when you go to your organic molecules, what you must know, organic molecules must be able to define organic molecule, must be able to know all your homologous series, must be able to define molecular formula, define structural formula, define condensed structural formula. You must know hydrocarbon, you must know homologous series, saturated compounds, unsaturated compounds, what is a functional group. These are your homologous series. This is all in your notes. Then the structural isomer, there are 3 types of isomers. There's a chain isomer, there's a positional isomer, there's a functional isomer. So you must be able to differentiate these and define these. And lastly, you have your properties of organic molecules: boiling point, melting point, vapor pressure. I will do this class sensor paper 2. And then there are your reactions, the last section of organic molecules: cookie oxidation reaction, esterification reaction, substitution, addition, elimination. So these are the reactions that you must be able to do. So in the video, I will do ZOI3 as topics. I will take November 2022, and then I will do Newton laws, I'll do momentum, I'll do vertical projectile motion in organic molecules from November 2022, which is the last year paper. So after that, maybe I will take 2021 3 topics again, 2020 3 topics again. If now you have a question on your channel, you can just send your question, then I will do it and then deposit it back. So in this video nizakwenza only this question 2. This is from November 2022, which is Newton's second law. And then in the next video I will do momentum. In the other video I will do vertical projectile motion, and lastly then the organic molecule. So all these are from November paper yakho last year, 4 questions. So let us look at this first question, which is question 2, Newton laws. So I'll read you a statement. The statement says crate P of mass 1.25 kg is connected to another crate Q of mass 2 kg by a light inextensible string. The two crates are placed on a horizontal surface. A constant force F of magnitude 7.5 newtons acting at an angle theta to the horizontal is applied on crate Q as shown in the diagram below. The crates accelerate at 0.1 meter per second square to the right. So as crate zombie is an acceleration, let's say the acceleration yazo yi-2 nansiya ku 0.1 meter per second square. So this is the acceleration, and then they say crate P experience a constant frictional force of 1.8 Newton. So crate P, which is this one, crate P une frictional force which is 1.8 newtons, and then crate Q experiences a constant frictional force of 2.2. So this one is experiencing a frictional force of 2.2 newtons. And then the question says state Newton's second law of motion in weights. That is 2 marks. Newton's second law of motion in weights. So you know the definition yakho in Newton's second law. Newton's second law. Okay, let me change the color. Your Newton's second law, you don't have to stress yourself. You can just say the acceleration is directly proportional to the force and inversely proportional to the mass. So write it here. Your Newton's second law is say the acceleration is directly proportional to the force and inversely proportional to the mass. Inversely proportional to the mass. So your first mark here, you will be the acceleration is directly proportional to the force, that's 1 mark, and inversely proportional to the mass, that's 1 mark. So that's how they give you that 2 marks. They will give you by stating acceleration is directly proportional to the force, inversely proportional to the mass. 2.2, draw a labeled free body diagram for crate P. Now here crate P, how many marks? Is 4 marks. So if you have 4 marks, then that means you have 4 forces that you must draw. So now crate P, then they want us to draw a free body diagram. Crate P is being pulled to the right by crate Q. So there's a tension between crate P and crate Q. So let's look at that one. So crate P, we have 2.2. So free body diagram represented with a dot. So to the right there is a tension, and then to the left you have your kinetic frictional force, and then towards the center of the earth you have your weight, and then the surface is exerting a force on the object, we call it the normal force. So for this one, it's 4 marks, that is 1 mark for the Newton force, the normal force 1 mark, 1 mark for the tension, then you have 1 mark for the weight, you have 1 mark for the frictional force. So let's go to 2.3. Calculate the magnitude of the tension in the string. Calculate the magnitude of the tension in the string. So we want now the magnitude of this tension. What is the magnitude of that tension? So this is crate P. Let me draw a free body diagram for crate Q, even though they didn't ask this one, but I just want to see something. So we have crate Q. We want to see how many forces that are acting on crate Q. So crate Q will look something like this. So for crate Q, towards the left, there are 2 forces. There is a tension and there is a frictional force. So there is a tension, there is a kinetic frictional force, and then you have now the diagonal applied force, so I'll call it F, and then you have the weight, and then you have the normal force. So this is object Q. So but we know that object Q has 2 components. There is this component, which is F of X, which is a force that is parallel to the surface, and then you have another force that is vertical, which is F of Y. So it's a vertical component of force F. So if you look at these 2 free body diagrams, so this is the tension from Q. So the magnitude of this tension from P and the magnitude of this tension from Q is the same, but it is in opposite direction. Magnitude yalingana, but direction is opposite to each other. So since we know the frictional force from object P, we can find this tension. But the problem with this one, we don't know what is the F of X because we don't know this angle. They didn't give us the magnitude of that angle. So we cannot use a simultaneous equation for E tension 2.3.1. So we can simply look at object P and substitute for a frictional force, and then you can find that tension. Here we don't know F of X, so we cannot use the simultaneous equations here. So let's look at this one. So for 2.2, we can say 2.2. First, let's take a direction. Our direction, let's take right, is positive for this one. So it's 2.2.1, 2.2, so 2.3, 2.3.1, 2.3.1. So I take right is positive. So if right is positive, that means that left is negative. Left is negative since right is positive. So this is my direction. You have to state your direction every time you solve this problem. State your direction. So we are looking now at the block or the object P. The object P. So for the object P, we use Newton's second law. We say F net is equals to ma. Now let's look again at object P. there are two forces that are pulling this one. The tension is pulling object P to the right, the friction is opposing that force of tension. So the normal force is not doing any movement to the object, the weight is not doing any movement, so we don't include the vertical forces Z to upper, only this F net. This F net means the sum of the forces that are causing the object to move. So we know that these are the horizontal forces, so the tension is to the right, so it's positive, but the frictional force is to the left, so it's negative, equals to MA. So if you take a right is positive, the tension is to the right, so the tension is positive. Force of is to the right, so it's positive, but the friction is to the left, so it's negative. And then let us look at our substitution. So upper we want the tension. So they told us the frictional force for object P is 1,8. So the frictional force for object P is 1,8. So we substitute 1,8 equals to, then the mass for object P is 1,25. So we substitute for the mass is 1,25. And then we look for the acceleration. They said the acceleration is 0,1. So we substitute acceleration here to offer 0,1. Okay, let me just put this thing in a clear writing. So we say T minus 1,8 equals to the mass we said is 1,25. The mass is 1,25. The acceleration is 0,1. So everything now is on place. Let us just punch calculator here too. So on the left you have T minus 1,8, then you need to multiply 1,25 and 0,1. So take your calculator, then 1,25 multiplied by 0,1. So we get 0,125. 0,125. Now we can take 1,8 to the right, so we have T is equals to 0,125. T was, the friction was negative, so when you put it to the right, it's going to be positive. So then your tension will be 0,125 plus 1,8. So your answer is 1,93. So the tension is 1,93 newtons. The tension is 1,93 newtons. How many marks was that? That was 4 marks. That was 4 marks. So they will always give you a mark for writing the formula. So the first 1 mark is the formula. So this is 1 mark. And then for substituting for your frictional force, there is also a mark there. And then for substituting for your mass and acceleration, there's also a mark there. And then lastly you have 1 mark. So that is how you get your 4 marks. Okay, let's continue. The last question says calculate now the magnitude of the angle. That angle. So but must phone again the angle of this force. So we go again to the free body diagram of object Q. Now we have 3 horizontal forces here. We have this one, which is the tension. We have this one, which is the frictional force, and then we have this other one, which is the F of X, a horizontal component of your force. So for this one we must remember F of X as a formula of F cos theta, and then f of y has a formula of f sine theta. But focus here to get is in these three forces, only the horizontal forces. Don't look at the vertical forces. Now the first one is going to the left, so it's negative. The second one is going to the left, it's negative. The third one is going to the right, it's positive, because we took right as positive. So you must remember right is positive. So let's go and do this one. 2.3.2. So 2.3.2, we have 2.3.2. F net is equals to MA. Always you start with that formula, and then we're looking at object Q. So we say we have f of x to the right, so it's positive. We have the tension to the left is negative. We have the frictional force to the left is negative, equals to MA. So now f of x is positive, frictional is negative, tension is negative. And then we substitute now. We say the formula for f of x is f cos of theta minus the tension minus, we do know the value for the frictional force. So remember, the value for the frictional force they gave us to be 2.2 newtons. So we substitute for our frictional force, which is 2.2 newtons. So the frictional force is 2.2 newtons. Then the mass of that object is 2 kg. So the mass is 2 kg and the acceleration is 0.1. So let's substitute for this force here. They said the force is 7.5. So the force is 7.5. So I'm going to substitute for the force here, 7.5 cos of theta minus the tension. So remember, the tension is ifumene power 2.3.1, which was 1.93, and we said that this tension is exactly the same magnitude or with the tension of P. The tension of P and the tension of Q, they have the same magnitude. So if the tension here is 1.93 newtons, that means that also the tension for this one is 1.93, but in opposite direction. So I'm going to substitute now for the tension for object Q to be 1.93, and it's negative, minus 2.2 equals to that 2 multiplied by 0.1. So I have to do now my calculation. So we take your calculator, then you have here 7.5 cos of theta minus, so we need to add these two, 1.93 and 2.2. So we have negative 1.93 negative 2.2, then we get negative 4.13. Negative 4.13 equals to, then 2 times 0.1, then 2 times 0.1, then we get 0.2. So on your right we have 0.2. Then you take the like term to the other side, so we have 7.5 cos of theta is equals to 0.2. Then take that 4.13 to the right, then you have positive 4.13. Now we have to add with these two, so take your calculator again. So plus 0.2, you just add 4.13. Then we have 4,33 on the right, 4,33. Now on this side now 7,5 cos of theta, because of sifuna theta, so we divide ngale singayifuniyo, we leave le siyifunayo. So let's first divide to 7,5. That's the right, we divide to 7,5, and then let's leave cos of theta on the left, and then let's see what do we get by right. So we have 4,33 divide by 7,5. So divide that by 7,5. Okay, it's 4.33 divide by 7,5. So we have 0,577. How many trees there? We have 2, 4, 6, 7. So you have to write all of that. 0,577, 1, 2, 3, 4, 5, 6. How many trees were there? 2, 4, 6. There was 7. So you write everything. We don't round off. We round off at the last stage. We don't round off in the middle of the calculation. So then cos of theta is equal to the inverse of all of this, which is 0,577333333, all of that. So which say second function cos, second function and cos of 0.577 and all your trees. Then your final answer now is 54,74. 54,74 54,74 degrees. So be careful here, we don't round here, we don't round here. So you must write all of that value and substitute it as it is before you can get to your final answer. So I think that was the last question. It's 3 marks. So here they will give you 1 mark for the formula between this one or this one, and they will give you the substitution for your tension and friction, and then you'll get the last one, the last mark for your final answer. That's how you get your 3 marks. So this is the end of question 2. So in the next video I'll be doing question 3, which will be your momentum. Thanks.